Hey guys, it's Cole, and today we will be graphing the polynomial function x cubed take away 4x squared take away 7x plus 1. I meant 10. To start this off, we're going to use the rational root theorem, which tells us our possible roots. So our possible roots, we'll put the last coefficient over top of the first coefficient, which is 1. So our possible roots for the last coefficient are plus or minus 1, 2, 5, and 10. And the possible roots for the last coefficient are 1. So now we're just going to punch some roots in there for x value, and we're just going to go with 1 first, which is going to give us 1 take away 4, 7, that's 10, which does equal 0. And now what we're going to want to do is we're going to want to use synthetic division to make sure we get 0. So I've already put the 0 down there. We're just going to bring the 1 down, which is 1, so negative 3. Negative 3 times 1. Negative 7 plus negative 3 is negative 10. Negative 10 times 1 is negative 10. And 10 plus negative 10 equals 0. So now what we're going to want to do is we're going to want to bring down our x value by 1 exponent from up here. So what that's going to do is it's going to give us a quadratic. So it's going to be x squared take away 3x take away 10. And now we can use decomposition. So what we're going to want to do is we're going to want to figure out what multiplies into negative 10 and adds into negative 3. It's going to be negative 5 and 2. Okay, so now we're just going to do decomp there. X squared take away 2x, no, plus 2x, sorry. Take away 5x, take away 10. So it's going to be take away 5x. We're going to get x take away 5 and x plus 2. And then don't forget, since this is a quadratic up here, we did have our function here, so that positive 1 is going to turn negative, and we're going to bring that down here. It'll be x take away 1. And now that we have all of our x's, we can turn them into zeros here. So we got x equals 5, negative 2, and 1. All right, so now we can look for the y-intercept by putting our x value at 0. Y and equal p of 0 there. Sorry about that. So that's going to be 0 cubed take away, sorry, p of 0 equals 0 cubed take away 4, 0 squared take away 7, 0 plus 10. So we know that these are all going to equal 0, so we know that our y-intercept is going to equal 10. And then just to plot some more points on our graph, we're going to figure out what p of 2 is, which is 2 cubed take away 4, that's 2 squared take away 7 times 2 plus 10, which does give us 8 take away 16 take away 14 plus 10, which means that our value at 2x is going to be negative. It's going to equal y equals negative 12. All right. Just another one. We're going to plot p of negative 1 there, which equals negative 1 cubed take away 4, negative 1 squared take away 7 times negative 1 plus 10, which does give us negative 1 take away 4 plus 7 plus 10, which does add up to negative 12. All right, so now we're going to plot our degrees and figure out how many turning points we have. So since we have a degree 3 polynomial, it means that one side is going to be up and one side is going to be down. And since it is positive, it means that our right side is going to be up and our left side is going to be down. And to figure out the maximum amount of turning points, we're going to go degrees take away 1. So the maximum amount of degrees we have is 3, which is up here, and then minus 1 is going to be 2. So that's our maximum amount of turning points. And then just to graph this, we have all of our values here. We have x equals negative 1, 1, 5. Our p of 1 equals 12. Our p of 0 equals 10, which is our y-intercept. And our p of 2 equals negative 2. So we're going to just plot these on the graph. So we're going to go negative 1, 1, and 5. We're just going to start down here. Make sure to include those arrowheads. We're going to go all the way up to 12 here. Come back down through our y-intercept. Down here, hit our 2, negative 12, and then up through our x equals 5 intercept, and just finish that off there.